Hello, polar bear buddies. How are you all doing today? Hopefully you are excited as I am, as this is our last day of our Winter Kids Club. Very sad, but very excited to be able to talk about our last habitat, in which we're focusing on the Arctic. So hopefully you brought your sweater. I forgot mine, but good thing I'm in a studio for now, right? But today we're going to get a chance to talk a little bit about the Arctic environment, much like what we see here behind, right? And our goal today is to investigate in different types of scuba diving equipment, as well as scuba diving suits, and about how scientists get a chance to observe the beauty that is the Arctic underwater world today. Now, if you do happen to have any questions, any comments, we'd love to hear from them. We'd love to hear you from them. And you can go on ahead and do so by texting us at the line below, 562-286-1838. And then if you do have any other questions that maybe need a little bit more of an elaborate answer, or if you're watching this after the fact, you're always more than welcome to email us down below at live@lbaop.org. Now, texting rates do apply, so please keep that in mind that you get adults' permission if you need to do so. So, our class today on the Arctic, as we are polar bear buddies, right? What a nice way to be able to end our week. So, what do you notice about this habitat? Is there anything that kind of comes to mind? Feel free to text in any kind of observations that you might make from this habitat. For me, I think something that I find really interesting is that the colors pretty much stay the same, whether it be land or air and sky, right? So it definitely has that bluish kind of coloration that we see, and a lot of white too. So a lot of that color might be reflected on from the sky up above. What else do you notice? Or could you potentially infer from looking at this habitat? Well, if there's ice, it's probably really cold, right? So that's an inference that we can go on ahead and make. But looking at this as an observation, right, definitely see that there's lots of ice that's all around. See big chunks of ice, right? Kind of some smaller chunks. And then even it almost looks like, almost kind of like gravelly ice that's right there, right? And smooth pieces and rough pieces and everything that's kind of in between. So a lot of textures are going on, even though all we have is mainly ice, right? It's kind of built up in different forms due to a lot of different kinds of disturbances, right? So if we think about this kind of really cold environment, right? What kind of animals do you think might live here? If we think about just kind of, well, on the land part. Do any kind of animals come to mind? For me, I kind of think of penguins, right? If I'm on one pole, right? If I'm in the Antarctic, that might be the case. Any other kind of animals that come to mind? Well, let me think. We might see like a seal or a sea lion, depending upon, well, more like seals probably, right? Maybe like a harp seal or something like that. But what about on the other side of the world, in the Arctic region? Well, give you a clue. It also deals with the name of our group. Polar bears, right? Ta-da! What beautiful timing, Stacy. And so here we have our lovely polar bears. So this is another animal, right? That lives kind of in between the land and the ocean interface, right? It definitely kind of lives and spends its day on land, but it needs the ocean and its inhabitants, right? All those delicious fish, in order for it to be able to survive. So with that, now, this is just a little bit about the environment itself, right? Knowing that it's cold, potentially windy, potentially sunny, right? We know that there's different types of ice that are present there in all sorts of shapes and textures. We know that there's water that's here, probably cold water, right? So it's not definitely kind of an unforgiving habitat, right? Very super cold, with water really cold as well. So if you were a scientist getting a chance to study in this kind of ecosystem, in this environment, more so underneath the water, what do you think some of those challenges might be aside from just the coldness of it all? Well, if you're thinking maybe the animals that live underneath, right? Definitely, right? That might be a challenge for sure. Any other challenges that you might think? Well, here we happen to go on ahead and notice that we have some water, right? But we don't necessarily know how much water there is. We're only getting a sneak peek in this small picture, right? But we don't know if it's just all ocean that's right behind, right? If there's shifting ice that's occurring, right? Or we don't know if there are any kind of icebergs or anything that's kind of moving, or if there's a certain flow, right? So there might be certain areas where the water flow may be really quick, and other areas where it may be really slow, right? So those might be some other challenges that they might face, whether it be the currents or maybe the things above on the water that are riding those currents, right? Whether it be ice flows or anything along those lines. So it's a really dynamic environment, this Arctic or the Antarctic region that these animals live in. Now, what's really incredible is that scientists are just visitors in this environment, right? And so there may be different ways to be able to study. What do you think might be some of those ways that you might study the underwater world? Well, something I think of right away is to be a scuba diver, right? And so that's a really great way to be able to explore the world. Now, for me, I'm a scuba diver in the Southern California waters, and I think it's cold, when really, in all reality, it's not super cold, right? But here in Southern California and in many temperate water areas, and also in many tropical areas too, we might wear a wetsuit. Now, the addition of the hoods or the gloves, definitely upon, personal preference, you may opt out of it if you're in tropical areas, or the thickness of your wetsuit may change too, or the style of wetsuit that you might wear, right? Now, here we have some of our colleagues right here in their dive gear, diving probably off of colder waters, so maybe off of Southern California, and they are all set, right? They have all of the pieces that they need to stay nice and warm and to be functional as a scuba diver. So they have their hood on to keep their head nice and warm, because a lot of the heat would escape right out of the head. And of course, they have all the things that they necessarily need, like the goggles, and this is where they breathe. It's called the respirator that's hooked up to their tank that's actually kind of behind their back right there, right? And they have their compass, so that way they know where they're going, and then their dive computer that helps them to know whether or not they're at a particular depth, and also how much oxygen. So there's like a little oxygen gauge that's on there too, right? So there's all these different components that really help the diver know what their environment is like. A lot of times there's temperature readings too that you can gain to see how cold the water is that you're diving in, or how warm the water might be too. But clearly it's a little bit cooler, as they are also wearing gloves, right? So that also helps insulate the hands. Now, if you had to think about it, right, as a wetsuit, well, it's a wet suit, right? So basically this suit gets wet, of course, because you're in the water. So how do you think might be a way that these scuba divers stay warm? Think there might be a built-in heater? Wouldn't that be nice? Maybe someday in the future. I could go for that. But what might be some other ways? Well, believe it or not, for wetsuits, what they do is you have your bathing suit underneath, right? And then you put your wetsuit on. And what ends up happening is a lot of the water from the wetsuit will go into, or a lot of the water will go into your wetsuit, where it gets sealed pretty much up against in your body. And so your body radiates heat, and it ends up warming up the water that's trapped between you and your wetsuit. Here's one of our colleagues in one of our aquariums right here. And so here, right, it's really cool to be able to see that warmth that you can get, and the comfortability of our colleague, right, in an exhibit. So it's really interesting that it's the warmth that radiates from our body that warms the water that's sandwiched in between our wetsuit and us, and then the wetsuit deals with the cold environment that's out around said diver, right? And so that's how you would dive a lot of times in warmer waters too. You might have your wetsuit, similar concept, right? But maybe you have something that's called a shorty. Basically, that's a wetsuit that's like shorts instead of pants, because believe it or not, they go all the way down, and then you have boots that you put on and then fins over that. But maybe in a tropical environment, you might not need all that wetsuit. You might get a thinner wetsuit, and you might have shorts instead of pants, and sometimes instead of the long wetsuit right here, right, it might be short sleeve too. So there's lots of different styles that you might be able to utilize it for diving, right? So surfing, wetsuit, kind of a similar kind of way, right? Now, what's really interesting is that the the colder water that you get, the thicker your wetsuit has to be. So could you imagine if you were diving in the Arctic, right? You'd have to have a really thick wetsuit, right? And then as you get thicker, you kind of have a harder time moving. So maybe if you're in a really thick wetsuit, you might be like a marshmallow and you might not be able to move. Now, what else is really interesting is as you go on ahead and you get a thicker wetsuit, you also end up adding buoyancy. Now, that basically means that the neoprene that's the material that the wetsuit is made out of is actually positively buoyant, meaning that you would float if you were in that wetsuit. All right. Now, with that wetsuit, because you would be floating, you basically need additional weights to kind of keep you down. And so the more neoprene that you have in your wetsuit, the thicker your wetsuit is, the more you might tend to float up the surface. So you have to add extra weights. So if you then happen to have a really thick wetsuit where you're like a marshmallow and you can't even really move, well, you'd be really positively buoyant. So you'd have to sink a lot. And then you're just not really functional, right? You're just kind of walking or just kind of swimming around, just kind of like almost like a human sea star, really, right? You can't really move a lot, and that's no fun if you're a diver, right? Part of the excitement is that agility, being able to swim around, to be able to check out really cool environments. Now, in the Arctic, right, it poses those similar kind of challenges, but luckily, diving technology has taken a turn and has helped out with that kind of problem. So instead, those that like to dive in really cold waters will use, as our dive volunteer Paul is showing off, a dive suit, a dry dive suit. So a little bit different than a wetsuit, right? We mentioned that the wetsuit, in order for you to stay warm, basically it's a barrier of cold water or a barrier of water that your body ends up warming up between you and the wetsuit, right? In this case, you don't have to wear your bathing suit. You can actually just wear normal clothes and you can go into the dry suit. So you just hop on in, put your little clothes on, and then you're able to then create almost like a suction where that dry suit just kind of sticks onto you. And you're able to stay warm by just having a layer of air in between you and the water itself. And so you get to stay nice and warm. And you also get to stay nice and dry. So it's a really cool adaptation that this dry suit has. Now, of course, will definitely most likely need, right? Here's another example of, a NOAA scientist going ahead and diving. You will still need very similar things to stay warm, if not higher grade. So in this case, also a hood, right? And you definitely need probably thicker gloves too. So we have some gloves right here. And everything else that this diver needs. And so you can see that dry suit that this diver is in. So it's pretty interesting, the different kinds of adaptations that these wetsuit makers and manufacturers have to make in order to dive in different kinds of conditions. Now, we did get a question of why do they need a snorkel if they have an air tank? That is a great question, right? Well, when you first get into the water, whether it be, tropical waters or the Arctic, doesn't matter, you dive in. And what you do is you basically, like I said, you're positively buoyant, right? Now, something that they have, regardless of where you are, is that you have this little vest right here, and that's called a BCD, or buoyancy compensation depth or vest, basically. And so with that, you're actually able to blow up, and it has extra air inside of it. And so you blow it up when you first go in because you want to make sure that you check all your gear when you're in the water. So you're just basically floating at the surface right about here, your face would be, and you're just making sure you have everything. And once everything is all secure and you're all good to go, you can then release the air out of there. And as you release that air, you basically sink down, right? And so this is kind of like a little flotation vest if you need it to be so. And so basically that's how you're able to go all the way down. And then you should be evenly weighted enough to be able to keep on diving. And then when you're ready to come back up, you would then blow that vest back up, and then you'd be floating up at the top. Now, there are lots of different uses that you can use for that snorkel, that mask and snorkel. Aside from, obviously, down the depth, you are getting air from a regulator, right? But maybe you are checking on your partner that went down first, right? So maybe you might want to dunk your face into the water, and as you do so, it's always nice to have that snorkel. sometimes when you get up from the boat, right, a lot of times you aren't directly next to it and you have to swim from your scuba point all the way back to the boat. And so sometimes depending upon the type of seas or, if you want to look as you're kind of, if you're on a snorkel on your way back to the boat, you can totally do that too. Or maybe you just don't want to get a mouthful of water as you're paddling on back to the boat. So maybe you just stick that snorkel in for easy breathing and you don't have to get like a mouthful of water as you're chugging along, right? So there's definitely several different types of reasons to why you might use that snorkel. But that is an excellent question. Because yeah, you wouldn't definitely use it while you're down in the depths of the ocean, right? And so here we go on ahead and we have our diver. Now, if we think about it, right? Our diver, what do you think might be some reasons to why, we might have divers go down into the ocean to study? How might it be beneficial to have an actual person go down? Maybe you might be thinking, well, they can do things with their hands, right? They're very agile, and you're right, right? So it's a really cool way to be able to go down into the water and to maybe if you're, putting cables down, maybe you need something that's, a lot more, that you need fingers and hands to do. Now, it may be a little clunky since you're wearing gloves, right? But it may be fairly easy to be able to do with a human. Right? We also talked about these ice flows, and maybe it's only large enough for a human to have to be able to go down to be able to do what they need to do, right? And also, nature documentaries. If you think about a lot of times, maybe there's photographers or videographers that maybe want to catch a certain angle that maybe they wouldn't be able to otherwise unless they went down into the water, right? So there's lots of different reasons to why you might have, as a scuba diver, to go down into the chilly waters of the Arctic. For me, I prefer some other methods. So, aside from a scuba diver, what do you think might be another way that scientists could explore the depths and get underneath that chilly water? If you're thinking maybe like a submersible or an ROV, absolutely, right? So here we have a submersible where we'd have people in a little bubble in this case, right? And we have all the different scientific tools that are attached to it that they can go on ahead and head on in. Now, I would imagine that these folks probably aren't in the tropics, right, with those shorts on, or they're probably in the tropics and not the Arctics, looking at the shorts that they have on, unless they really run very, very, very warm, right? But for these folks right here, this might be another good way to be able to check out what's going on in the ocean, right? You still have people that are in there, usually have like a sub pilot, and then you might have one or two scientists that are down there too, getting a chance to really take a nice look at whatever they happen to be studying, right? But the interesting thing is, whether it be a scuba diver or submersible, right? There's still people that are involved. And people need to use the bathroom at times. People need to have snacks, right? And people can only be down at the depths, whether it be in a submersible or scuba gear, for only a short period of time. So what do you think might be another option? If you're thinking something that's more robotic, you got it, right? That would be like a remotely operated vehicle like we have right here. Now here it looks small, right? Like it could fit in the palm of my hand, but these are about the size of, well, a large SUV, right? If not, maybe like a little bit taller. But these don't have any people inside of them. Instead, they have people controlling them from a boat, basically. And all that information is brought by that tether that you saw there. And this is what it looks like within their control room. I'll step out for a second. But there we can see all sorts of different monitors, like a ton of different monitors, right? We can see monitors everywhere, and they all have their different uses. Now, some of them are currently showcasing the ROV, so you can see it on deck, which is important for launching and bringing it back in, right? And so we can see it even from a top angle, which is very useful, and all sorts of different angles, right? We're able to basically see the bathymetry of where they might be going, right? So getting a chance to understand the sea floor, because it might be helpful for a pilot to be able to get a better idea of what kind of environment that they are driving this remotely operated vehicle in, right? Are there, just like in the ocean, or on land, there are mountains and there are valleys and peaks and everything in between. So we want to make sure that the ROV doesn't necessarily crash into anything, right? And then here, this would be more where the cameras that are mounted on the actual ROV, all the images that you would see would be right here, right? And then here's sonar as well, so I can get a good view. Now, ROV pilots are only one part of the entire ROV party, right? So there's the navigator that goes on ahead, and the navigator talks to the captain of the ship and make sure that there's enough cable that's out there for the ROVs, but it also allows them to be able to make sure that the ship is doing a similar dance, right? Is going in a similar direction to where the ROVs are going, so that way they're always in tandem with each other, right? There's also video engineers that are on board too to make sure that the color and that they're able to see the correct color, but also to be able to control the zoom lens on that camera too. There's scientists that are on board getting a chance to look and ask for different kinds of samples that are present down in the depths too. So there's a larger team, right? If we think about the scuba divers, it's only like one of them and maybe that's down there, maybe two, right? Just a few. It's not like a whole party of people. And if we think about that submersible, right, there's only maybe about like 3 people max. But this way, it allows a diverse set of folks to be able to truly investigate those waters and really maximize the amount of time that ROV can spend down there. Because it doesn't need bathroom breaks, right? And it doesn't need snacks. It only needs maybe a rotation of people, of pilots and scientists, to be able to switch off every few hours to keep that ROV down and going and check out as much as they can. Now, we did have a 6th grade class ask, they're learning about cold ocean currents. Do these currents affect divers? That's a great question. And they absolutely do affect divers, right? So something as a scuba diver, and as you become more advanced or you dive more often, you are aware of these currents. It's always good to be able to dive with a buddy, and sometimes if you can know a little bit more about where you're diving, then that really assists you. But many times when you go out diving, you can go either from the shore dive, so you can do like a beach dive where you walk down to the shore and then you just dodge a few waves and whoop, down you go, right? Alternatively, you can do boat dives where you're on a boat and then you just kind of do a really big leap and then you head on into the water, right? And so no matter how you end up choosing to dive, there's usually, you might do a little extra research, or there's like a dive master that's there that can also kind of help fill you in. So if you're on a boat, for instance, and you're diving at a place that you're not as familiar with, then usually the person that's kind of in charge will help. Either they'll be down there and they will guide you through the area and they will know of the currents, or they might tell you ahead of time, or that area may be very well known for currents. And so what you can do is you can kind of chart your dive depending upon those currents. So that way you don't get tired, or, if those currents are ever unsafe, you want to be very careful and vigilant of them. So sometimes what you could do is you can go to one area that has less currents, and then, your dive boat can be in one spot, and then you can ride the currents back to the dive boat. So that might be a nice way to be able to ride currents and to take advantage of them if they happen to be in the area. Other times you might have other methods or other ways to kind of look out for currents. Sometimes the bottom of the ocean, you can see or sides of the ocean, you can see different channels that are maybe carved out of the water. And so, that might be areas where you might want to avoid, or might be, if you can safely check that out, you can go on ahead and do so. But there's also a lot of diving that happens in rivers too. And so you would basically be riding the currents of those rivers as well. I know my in-laws, they're avid divers, and they used to do a lot of cold water diving up in like Minnesota and Michigan. And so they would go in all the different river systems during the winter time out of all times, and they would ride the currents of the rivers. And obviously you start at one place and you end up further on down in the area, but it's pretty neat. So currents definitely are something to think about. And then we got another question of what kinds of things they study in cold water. Great question. I send that question back out to all of you. What do you think they might be studying in those cold waters? Well, if you're thinking animals, Yeah, right? So they might be studying just like how we have off of our cold water coast, right? A lot of scientists might study different kinds of animals that are present, especially in areas like the Arctic and the Antarctic. There's some areas that in the deep ocean, a lot of places that are still really unknown. And so maybe fish or different marine mammals might be the interest of study. Also, maybe sea ice might be the interest of that study. So maybe there's a way to be able to drill down deep into the sea ice to then be able to get a sample of sea ice and see what kind of gases might be trapped there, what kind of plankton might be trapped in there, and they can find a lot of information from the sea ice itself. There's also the sea floor that's down there too, much like on our environment, right? So maybe they're interested in looking at the geology or the chemistry of that sea floor, right? What is it made out of? Are there bacteria that are living down there? Are there certain animals that just prefer to be, sedentary and live on that bottom of the sea floor, right? So there's tons of different things that scientists can study, even the invisible. So even like the plankton that live in there, they may want to take a certain sample from that particular area to then be able to bring up to the surface. Now, talking about sampling, right, ROVs are great at getting a chance to sample. And so here's an example of such. And so here we have a scientist that seems to be interested in corals from what I can tell from this picture, as there are some varieties. And so here's a little collection bin, and a lot of times these are little drawers that go in and out of the ROV, kind of like if you think of your own dresser at home, right? There's kind of like the dresser drawers here too. And we have different kinds of arms that are great at being able to pick up different samples. Now these look hardcore, but they're actually quite agile in how they're able to be used. And so here we have that arm being nice and gentle on that piece of coral right there. What else is really cool is that it's hard to see colors when you're that deep, right? The colors actually go away. And so what video engineers are able to do along with the ROV pilots is to be able to bring the colors so that way they can get a better idea of what they're seeing, right? Now there's a light on that ROV too that's shining out, but the video engineers are then able to use this little color palette here to then kind of balance the colors to make sure that what they're seeing is the actual color that they're seeing. That's pretty neat. Now, there are lots of other different kinds of tools that are on board ROVs. Sometimes they use little suctions to be able to collect animals that maybe aren't as hardy as these corals, that maybe might be gelatinous, or maybe they want to take a core sample of what's down below. Whatever it may be, there's different tools. So here's an example of a collection part of the actual suction. So a vacuum is another way that they can collect animals, and then they each have their own labeled tube right here so they can collect a wide variety of samples of animals and just put them in each tube, pressurized tube. As the ROV comes up, they're then able to collect these animals or whatever they happen, animals or algae or whatever it is that they choose to vacuum up, right? So there's lots of different tools that are available. Now, what's really exciting and what I think is my favorite part is the fact that all of you will get a chance, if you so choose, right, to join in on our activity at home. And so with that activity, the goal is for you to try to kind of build your own ROV. And I mean that in a figurative way, but also as an actual way. So I want you to be able to think about, what does your ROV look like? What kind of tools do you want your ROV to have, right? What kind of instruments do you think might be useful? Are you going to take the temperature of the water, right? Do you want to build different robotic arms to be able to collect all that? Do you want to have these little collection tubes, right? However you want to design your ROV to collect different samples, you can go on ahead and sketch that out and talk about all the different ways in which you can use your ROV. Now, if you want to take it one step further, you can actually start building it. Now, I don't mean you can, if you feel like you want to, work with electronics, you're more than welcome to, but ours is a little bit more simpler, right? Our ROV that we are inviting you to potentially design would just be kind of like a mock-up, right? So maybe you have like a shoebox that you want to have as the body, and then maybe you want to use some toilet paper rolls to then kind of build out your suction arm, or however you so choose to make it, right? You're more than welcome to utilize any kind of materials that you have at home to be able to build your ROV, right? And as you go on ahead and do so, if you're interested in sharing that with us, we'd love to see what some of your creations might be. And you can go on ahead and share with us if you'd like at hashtag AOP Kids Club. We'd love to see all of your different engineering feats and the different kinds of ROVs either that you make, or you can share with us your drawing of what your ROV would look like, right? What kind of tools would it have? How would it use? Where would it study? Today we've been focusing a lot on the Arctic, but if you're like, I'm actually more interested in the deep sea, or maybe I prefer to look at tropical oceans, you could totally make your ROV to do that as well, and you could tell us a little bit about the kinds of things that you would sample there too. All right, well, this is the end of our Winter Kids Club, friends. It's been absolutely wonderful being able to share this time with you, but not to fret, we do have our Aquarium Online Academy that will be starting up again next week. So we hope to see you then too, and have a great rest of your weekend. Bye.